Have you ever been curious how influential gases in the atmosphere affect the climate of our planet? Well, look no further than this awesome Minecraft video. Today I will peacefully demonstrate what the greenhouse effect is, what the carbon and nitrogen cycle is, how greenhouse gases trap heat into the atmosphere, and dive deep into the chemistry behind the gases responsible for this, such as carbon dioxide, methane, nitrous oxide, and sulfur hexafluoride. Grab your thinking hats, or maybe military gear because it's about to be the bomb. An overview of the greenhouse effect. The greenhouse effect in simple terms is atmospheric gases trapping heat they receive from the sun, which in turn warms the planet. When the sun emits its solar energy in the form of ultraviolet lights, which is a type of shortwave radiation, about 30% of it gets deflected into space, 20% is absorbed into the atmosphere. The remaining half is absorbed into the Earth's surface and re-emitted back as heat in the form of infrared radiation. The reason why they don't all get absorbed into the atmosphere is because UV radiation has a higher frequency, and it requires significantly more energy to absorb, while infrared has low frequency and requires significantly less. The re-emitted heat from the Earth's surface is what causes the planet's temperature to be as warm as it is now. If it were to all be deflected into space, we would be in the Ice Age. Carbon and its cycle. The most abundant greenhouse gas of all, except water vapor, we don't count him, is carbon dioxide. This compound has a process called the carbon cycle, where a carbon atom moves between different reservoirs and gets released as CO2 into the atmosphere. These reservoirs are fossil fuels, the ocean, and land. The ocean exchanges CO2 within the atmosphere and turns it into carbonic acid because of its solubility. Since carbon is the building block of life, large amounts of carbon is stored within the biosphere, and its addition to natural processes such as respiration and photosynthesis. Fossil fuels, on the other hand, are recent. Just 200 years ago, we started burning these fossil fuels for energy, and this had released millions of years' worth of biomass in just a couple of centuries. How gases get trapped. But how exactly do these gases get trapped in the atmosphere? Well, the greenhouse gas goes into the atmosphere and diffuse amongst themselves. Once there, photons will hit these molecules and the gases absorb them. Bonds between the molecules usually bend or stretch in a way to try and reach these photons. Once absorbed, energy from the photon gets the molecule into an excited state, and when it's done utilizing the energy, they release it back in the form of heat. Methane and geometry. Methane, while not as abundant in the atmosphere as carbon dioxide, can hold up to 120 times more heat than CO2. The difference in the amount of heat they can carry is in their geometrical shape. The more complex they are, the more heat they store. Atoms and molecules constantly move around each other, getting closer and further apart while vibrating. When this happens, they bend and twist into an asymmetrical shape which produces an electric field that attracts photons. Since methane is geometrically more complex than carbon dioxide, they can store more energy from within. But carbon dioxide can last up to 100 years in the atmosphere, compared to just a couple of decades from methane. Nitrous oxide and nitrification. Nitrous oxide is a frequently utilized compound that is used in the agricultural, medical, and automotive industry. However, they are capable of holding more than twice the heat than that of methane, while lasting just as long as carbon dioxide. Nitrous oxide is produced as a byproduct from ammonia and nitrate. It requires a two-step process called nitrification and denitrification with the help of specialized bacterias. Nitrification involves ammonia and an ammonia-oxidizing bacteria to produce nitrogen dioxide. Then through denitrification, a denitrifying bacteria is used on nitrate to make another nitrogen dioxide. After that, the two nitrogen dioxides get denitrified into two nitric oxides, which finally get denitrified again into nitrous oxide. All that struggle just to make funny gas. The big bad sulfur hexafluoride. Sulfur hexafluoride is the only purely man-made compound in the list. This is the most geometrically complex shape amongst the other gases and can hold thousands of times more heat than carbon dioxide while lasting hundreds of years longer. Mankind never fails to disappoint their home. The compound is used in circuit breakers, particle accelerators, and ultrasound. It is very inert and stable, but once it decomposes, it releases highly toxic and reactive gases, most of which are potent greenhouse gases themselves, and its low solubility in water makes it impossible for nature to get rid of. These gases do sound amazing for the environment. I mean, what's a couple degrees hotter on Earth, right? But you know what is worse than a scorching hot planet? Allergies. I'll demonstrate to you why we should care about global warming, because it's not just temperature that's being affected. The process of allergies, pollen produced, is influenced by heat. That means the hotter it is, the longer and earlier pollen season starts. Hay fever is a common symptom during this time, and it starts with the seed. Once pollen comes in contact with your body, it releases a hydrophilic mixture of allergens and molecules. Since the body doesn't know if it's harmful or not, they release epithelial cells as a first line of defense. Once anti-inflammatory responses in the body start running out, allergic inflammation sets in. To capture these allergens, dendritic cells create a network throughout the respiratory system. This is what causes the stuffy nose. Once captured, antigen-presenting cells degrade them internally. So, should we start protesting to the government to blow up these factories that produce such harmful chemicals? Maybe, maybe not. It's important to realize that just because you don't know what's going on doesn't mean you shouldn't care or ignore it. The sooner we stop producing these harmful gases, the easier it is for the Earth to break them down. Hope you enjoyed the video, and have a great day.